Ladies and gentlemen, welcome to a special on-site episode of Weld Wednesdays with AWS, brought to you by the American Welding Society. This recording session took place at the Welding Automation Expo and Conference in Columbus, Ohio, October 10th through the 12th. It was a great event, and I am so glad I was able to attend. The conference consisted of 2 days of presentations by several manufacturers, OEMs, suppliers, distributors, and end users. The presentations concluded with tours of the Ohio State Welding Engineering Program and the Edison Welding Institute. Welding automation has actually been around for over 40 years, but now that they're becoming more customizable, easier to program, and more affordable, industry is adopting automation at a rapid pace. When most people hear about welding automation, they immediately think it's going to replace welders. But a common theme amongst all of the presenters at the conference was that welding automation is a supplement, not a replacement to the physical welder being on site. Automation actually helps with the repetitive, mundane weldments that take place in a shop, freeing up the welder to focus on more complex weldments and also the programming and supervision of the welding robots. I learned a ton of great information while attending the conference, and I'm already planning to attend the next Welding Automation Conference in 2025. In this episode, I'm chatting with Corey Mays, owner and operator of CM Welding and Machining, located in Midland, Texas. Corey and his team serve the oil and gas industry. Corey started to adopt the use of cobots in his shop several years ago to help out his team and decrease the wait time for his clients. As you all know, oil and gas is a fast-paced industry, and when something goes down or they need to redirect resources, it needs to happen yesterday. Corey knew that to remain a solution for his clients, he needed to automate his shop. Let's go ahead and check out his story.
Arc Junkies presents Weld Wednesday with AWS. Brought to you by the American Welding Society. And now your host, Jason Becker.
All right, ladies and gentlemen, joining me today is Corey Mays from CM Welding and Machining. So welcome to the Welding and Automation Expo and Conference here in beautiful Columbus, Ohio.
Great.
It's been a good event so far.
It's been really, really informative. You know, I was really surprised to get asked to speak. You know, I'm just some dumb welder, you know, from out west. They want you to come talk about cobot welding and welding automation, so here I am.
Well, I thought you had a great presentation, especially because, I mean, you kind of got put in the worst possible time frame. Anybody that speaks after lunch, you know, they've got a difficult path ahead of them because everybody's kind of like tired, you know, the food's settling in. Mm-hmm. It's middle of the day, but I mean, you knocked it out of the park, dude.
Well, I appreciate that. I'm presenting is not really my forte, you know, but I hope it was informative. So
yeah, you could have fooled me, man. I mean, like you went up there and took the stage, and you did, like I said, you did an awesome job. And I like the way that you got your company kind of laid out. You know, some of the things, well, actually first, because we're at the automation conference, let's talk a little bit about automation. So you tell me a little bit about your company and why you decided to get into, you know, to start automating some of your processes.
Okay. So most of the stuff that we started out automating was really upstream processes, plasma cutting, pipe tube profiling, a lot of brake press work, forming, and things like that. We have a couple capabilities in the I guess what you would consider conventional robotics, but those are really product line tied. There's only about 2, maybe 3 parts that are built with those, so it's really constrictive to try to open that system up to, say, like job shop manufacturing, high mix, low volume type work. But you know, the collaborative robotics has come a long way, especially since we were introduced to it in 2019. We bought unit number 4 that Vectus ever created.
Oh, wow. So you guys jumped in early.
We jumped in really early. I guess for me, the biggest attractor to it was really the open cell. We worry about safety with closed cell robotics and things like that. You don't really want anybody in there working in that environment. And having an open cell, the safety features a lot of flexibility was really attractive to us, because then that fits real well with, high mix job shop manufacturing type of work.
Mm-hmm. But you guys are all in petrochemical, and when I think people doing work for petrochemical, I automatically don't think automation. I think that's all done like manual welding on a rotator, or you got a guy or a gal over there performing all the welds manually by hand.
Yeah,
but you guys automated some of this stuff.
Yeah, there's quite a bit that can be automated. I mentioned about approaching automation strategically. There's a lot of companies that I've worked with in the consulting world where they might approach it and say, well, we've got pipe spools or something that it tends to be a bottleneck, and the automatic answer that they come up with is, well, we got to get a robot to do it. And that's really, for piping, that's really a little bit more difficult than one would think, because if you get a pallet of flanges, they can all be the same class, the same pipe size, but the dimensional tolerance on a set of flanges could vary, up to 1/8 of an inch. And for conventional robotic welding, your closed cell type systems, that's really that adds a lot more time to shifting work offsets and everything. So every spool you put in there, it's essentially going to be different in length. So your weld center is going to be off and things like that. So there are a lot of, spool welding robots. And, I think NovaArc has a really awesome system. But you better have a lot of spool work to justify that capital. So for us, we manually weld a lot of our piping. Now, all of the associated components that come in with that, say like for facility fabrication, pipe supports, brackets, all of your catwalks, all of the other stuff, that's fairly easy to automate, especially using cobot. So
yeah, no, it's pretty cool, because you got a very unique layout where you're at. Because you have an apprenticeship model. Mm-hmm. So you said you actually bring welders in and you train them up in the summer. Or was it the spring?
Summer.
Okay,
yep.
So you bring them in the summer, which is like the ideal time, because you also recruit and work closely with your local high schools, which is something a lot of manufacturing companies don't do. They tend to shy away from working with trade schools and stuff like that, but then they want to say, oh, I can't find any welders anywhere.
Yeah.
But you've adopted a model that I've been jumping up and down and screaming about for the past couple of years, is why don't you go down to local high schools and tech schools, recruit directly from there, bring them into your program, and then train them up to work, exclusively on what you're doing. And it sounds like that's exactly what you're doing at your shop.
Yeah, absolutely. Yeah, kids coming out of high school, the vast majority of them don't even have a clue about what manufacturing is, much less welding. Through our apprentice program, junior year and senior year, you get your summers where you can work essentially as part-time, but full-time during the summer, and you get really immersed in all the different aspects of what we do, because we cover a broad range of product lines and services and stuff, from machine shop services all the way to welding and fabrication. So through that process, they get an idea about what manufacturing is, and we're able to look at them from an outside perspective and really figure out what their strengths and weaknesses are. Some guys are come in, want to be welders, and just as well as an educator, there's a lot of them that sometimes just it's not going to work out.
Yeah.
And you hate that, but there's also opportunities over in the machine shop. They're good with design, they're good with working with drawings, they're good with interpretation. They may be really good with dimensional inspections, checking parts and stuff like that. So we try to use that not so much as a full-on training at that point, but really an immersion, kind of tiptoe in the water, so to say.
Mm-hmm.
So,
now, are you recruiting specifically from welding programs, or pretty much just anybody in that high school with an interest in getting into manufacturing, machining, and welding?
Yeah, anybody in that high school that's got an interest.
Okay.
Yeah. We have now with the local welding schools, we have a like a tuition reimbursement program. So like if they decide, hey, I want to get better at welding and I want to be a welder, I want to make that as a career and not just use it as a job, then once they get out of high school, we'll work with them and say, if you want to go ahead and get like your associates at a tech school or one of the local colleges in metallurgy or weld science or any of those subjects, we'll do a tuition reimbursement with you. We'll help out with that, because most of those classes are night classes anyway, and they don't really interfere with the work week. So, if they do, we kind of we help them out with that too.
Okay. So now, do they become during your like summer apprenticeship program? Do they become an employee of the company while they're going through that apprenticeship program? And is it a paid apprenticeship?
It's a paid. Yeah, they're full employee. I've got a lot of I've got a couple that are still in high school, and now the high schools have a work program to where they can get like their shop credit if they're working for a manufacturer. We just have to do the paperwork at the end of each week, proving that they've been working for us. They're not goofing off at the house.
Mm-hmm.
But yeah, so they're full on employees. They're paid.
That's cool. So even like during regular class, when school's in session,
mm-hmm.
they can actually take or work at your facility and get class hours, so they can work throughout the year and then put in some additional hours during the summer.
Yeah, absolutely. As long as the school has that system set up, which several of the high schools in our area do, that's what they do. They get paid to practice.
Now, when did you start this apprenticeship program?
We kind of developed it over a long period of time. I'd say right around 2012, 2013, right around when the second to last oil bust, so to say, happened. We really, I kind of got quite honestly, I got fed up with the quote unquote skilled labor coming into our company, and it just seemed like we had a lot of guys who had a lot of experience, but they also brought in a lot of bad habits. And I don't know if that's, conducive to just our area or...
No, that's everywhere.
Yeah, I'm sure it's everywhere. But so we started thinking about, we really need to start training our processes so that they can come in and be proficient in what we do. And, there's more than one way to skin a cat, and I understand that. You go to another company, they're not going to do it the same way that we do it. But for our product lines and our processes, it works well that way.
That's anytime I'm into a training situation when I'm working with other people, that's one thing I always tell them is like, I'm going to teach you the right way. Mm-hmm. You can learn your bad habits elsewhere.
Yeah.
But this is the way that it should be done across the board. It's not based on my opinion. It's, factual. It's either out of a code book or out of a safety manual or whatever. I'm going to teach you the right way to do it. You can learn your bad habits somewhere else.
Absolutely.
That way, once they're coming out of school, they really don't have bad habits. I mean, they're all tuned up with safety. They understand the welding parameters. They understand, attention to detail, work ethic, showing up on time and all that stuff, so that once they walk into an employer, I mean, that's yours. I mean, you've got a good product, you figure out how to implement it the best way for your program or your company.
Absolutely.
But I like the fact that you started doing that way before there was like a welder shortage. You started implementing cobots into your program, developing an apprenticeship program before there was a skilled trades talent issue.
Yeah.
So have you noticed throughout, because everybody's jumping up and down for welders right now, have you noticed that, kind of planning that out way ahead of time has helped your company not really fall victim to the current labor shortage? Well,
we see it a little bit. I don't think anybody's really immune to that, but it has helped quite a bit. I'll be honest with you. I think two things that we tried to do is implement automation strategically to where we didn't have those labor shortage woes, but at the same time, it's important to start developing that workforce simultaneously. I think I mentioned doing it parallel instead of one being dependent on the other. And through that, we've been able to. I feel like we've been able to be successful with it. We haven't, the way that we run the operation. I think if I didn't get a chance to mention it, but when I laid out all of our different departments, you look at all those different departments, you would think, man, those guys probably have like 100 employees. We got less than 20 employees.
Oh, wow.
Running that thing. So it's extremely lean, very efficient, and I like to keep it that way because it allows me to really invest not just money and capital into our workforce, but ultimately invest time, which is a commodity that you're never going to get back once you give it away. And I think time, when you invest time in your employees and invest time in building those relationships and letting them understand that, I care more about you, not just as a, say, like an investment in a machine. I'm not just considering you a welder. I want you to better your life and gain more skills. Let's do this together. Let's train, let's practice it, let's develop it together so we can all be beneficial. You're going to make me money, but at the same time, I'm going to make you money too, And to an extent, a lot of kind of naysayers has always said, well, you're just training your competition. I have yet to have anybody leave and go to another company, and especially coming out of that type of program. I've had, occasional bad apples as employees. Everybody does. But as far as going through that type of program, they're all still there, and they're all still daily improving their processes and techniques.
Yeah, I was just speaking with the folks over at Fronius about that. I talked to them at FabTech, and they have an employee training program, and they specialize in that, so they have a very low turnover rate because some of the things that they do with their employees is figure out, how do I motivate this employee? How do I make them want to work here? How do I provide value to them and show them, like, here's a pathway. Like, what do you want to do? Where do you see yourself in the next 5 years? And obviously that's a very cliche question for like the interview process, but they look at it from a different perspective. Instead of saying, hey, where do you want to be in the next 5 years? And they always get, the same answer, over and over, like the boilerplate textbook answer.
Yeah.
They essentially take that information and say, okay, let me help you find a way to get there.
Right.
And so that gets, the employee's attention. They're like, what? You're going to actually provide me a pathway to success to do what I want to be able to do? Well, yeah, because, if, let's say you start off as a welder and you're, running the cobot or, whatever the case may be, but your ultimate goal is to get over there in the machine shop, I'm going to provide you a pathway to get over there. Mm-hmm. So I'll take the skills that you have as a welder, I'll give you everything you need, but then maybe during the apprenticeship program, when next summer comes around, I'm going to put you in some of the CNC classes.
Yeah, absolutely. And it's important to, I feel like it's important to understand that feedback from the employee as well, because, when you have problems or you have potential bottlenecks, sometimes as an owner or higher up management, you're not really seeing what's going on the shop floor. So if you're building up that rapport and that loyalty to where they know, hey, these guys have our back, a lot of times there's going to be less of a hindrance to them bringing up an issue. Say, hey, we're seeing this. We want you guys to start working on a solution. We've got some ideas that might work. Because I think that whole process, if you give them some ownership in not just the problem, but also the solution, that builds a really good workforce and a really loyal workforce as well.
Yeah, that's one of the problems I always face coming up through the ranks as a welder is like, why don't they, I'm out here, doing the work.
Yeah.
I can see the problem.
Yeah.
I told them what the problem is. I told them what the solution is. But they want to keep doing it this way because, that's the way we've always done it. Well, How about we increase productivity, we increase speed, and we decrease accidents by doing it a different way?
Yeah.
Understand and value. I mean, when you hire an employee, you're hiring them because they're an alleged subject matter expert. Take their advice into consideration when you're, planning out some of these day-to-day operations or how your shop is run or, preventing bottlenecks like you were saying.
Right. Yeah. And I think for the vast majority of automation that we've implemented, most of the process bottlenecks have been brought up by our workforce. With the prefabricated facility game, we got really good at it because our employees were on board with bringing on some automation to help them out because they saw that all of the upstream processes were, for the most part, automated. and they could kind of see that tidal wave of parts coming at them, and just being realistic with me and not being afraid to say, we're not going to be able to get this done. That fear's not there. They brought it up and said, hey, I can see a potential problem happening here because of this, this, and this. And I said, well, let's take a look at it. Let's go see if there's an answer to it. Mm-hmm. So, of course, that's where we got the cobot answer.
Right. Now, like I said, when you think petrochemical, you don't automatically think of automation. So are there other companies, in your area that also work in petrochem that are incorporating cobots and robots, or are they still kind of stuck in the ways of doing it manually?
No, there's quite a bit of what I would consider conventional robotics. It's very process based, product line based. A lot of the pump manufacturing companies, they'll utilize closed cell robotic type systems, the cladding, weld build up, weld repair type services. A lot of those guys are utilizing conventional robotics, but as far as collaborative robotics, I haven't seen anybody really touch that yet.
Now, what was it that made you go with a cobot versus closed cell? Just the tolerance issues, like you mentioned before?
Well, a lot of things. Tolerance. We're moving over into more of a high mix, low volume type manufacturing. Our clients, and I was talking to Doug earlier about how oil and gas, not from, well, let me back up. Let me say, when I refer to oil and gas, I'm referring to the production companies, the actual oil companies. Their gathering lines, their well equipment, the facilities, the infield facilities. That's before it gets to the pipeline, all of that infrastructure there. But that sector of oil and gas usually kind of lags with the advancement of technology that's out there. So it's, there's a lot of aspects of it that are still stuck in a decade ago. That's the way we've done it. But yeah, the to your question, the answer to that, I think, is just really thinking critically and really coming up with outside the box solutions to a lot of things. And for the most part, you have to not really show your cars to the customer and how you're doing it, because they don't really want to know anyway.
You're just getting it done.
Just get it done, and we need it now. So.
Well, because that's what you were saying earlier. You pretty much run 24/7, because when they call, they need a solution now. Mm-hmm. They need it yesterday, and they want to buy it for a decent price.
Yep.
And like you said, we can do it. We can do it good. We can do it cheap. We can do it fast. We can do it expensive. I mean, you pick two of the three.
Yeah. And a lot of times, it's easier. So our model, we're going to sell the quality. We're not going to differentiate on that, and we try to give them the lead time, tight lead times, and I'll bicker back and forth with them about the price once they get the product. Once their problem is solved, they tend to not, be so squeamish on how much it costs.
Mm-hmm.
So.
Yeah, once it's in and it's working, the problem's been solved. Yeah, okay, now we can relax. We know exactly what we're getting for the price we're going to pay, and it's well worth it at this point.
Yep.
Everything's back up and running.
They're good to go. I mean, they for the most part, it's just you're buying time. They're really paying for time. So
now, do you think switching over to cobot or automated systems, do you think that's been able to increase your productivity time to be able to, once you get that call 3 o'clock in the morning, you can get in there and get the products out much faster to kind of meet their tighter deadlines?
Absolutely. The time to finish part is substantially less than conventional robotics for obvious reasons. A lot of our customers that we supply, say, weld assemblies or their own product line, they, like I said before, they kind of lag with the way the rest of the industry kind of goes. So probably about 8 years ago, we started seeing the shift to a just-in-time inventory model, and that started creating a need for us to shift as well to that high mix, low volume type manufacturing. The thing that we didn't foresee was, of course, the pandemic happening and the supply chain issues that followed. So one of the things we're finding now is a lot of the parts that we would consider off-the-shelf parts, we have to physically make them. That's what our machine shop spends a lot of its time doing, is making key components that we used to be able to find on the shelf. We just have to make them in-house, so it's not holding up our weld assemblies down the road.
Okay. So are you able to, like, over in the machine shop, are you producing your own flanges now?
Occasionally, yeah. If it's a custom type flange, or if a lot of what we would consider spec brakes, where you go from API type flanging to ANSI flanging, your normal B31-3 type flanges, all your wellhead equipment is completely different flange standards than, say, your production equipment. So there's a lot of spec brake, custom flanging, and things like that you have to make. Those type items really weren't on the shelf anyway.
But be able to do all that stuff, perform it in-house, not have to rely on a secondary company to produce that for you. That's also helped with kind of supply chain issues.
Absolutely, yeah, and we're able to pass that benefit on to the customer too, being able to quickly come up with a solution to a problem. Once they see that benefit, that we're not just supplying your part, we're training and equipping problem solvers to be able to benefit you. Those customers, we're able to build quite a bit of loyalty with them because of that.
Because you can solve their problems.
Yeah.
Now,
absolutely.
Do you guys ever do? Have you used the cobot to do any rollout work?
No, we don't have the fourth axis capabilities on it, and really, for that matter, it stays so busy doing the monotonous tasks, the high volume stuff, the high mix. It's really versatile for either one of those situations. The ability to have something being done or tacked up or welded while the welders or fitters are doing something more critical or more, I would say tighter dimensional tolerances than what the cobot could put out. That's enough benefit for us. I really don't have much of an desire, I guess, to say, to push it any further.
That's, I was just wondering if you could, if you get like a regular pipe rotator, set it up on some jack stands, get everything tacked up, and just have that, because the cobot's open cell, so it can just reach over there, hit it at that 10 o'clock angle or whatever, and it can start rolling at the same time, that kind of trigger the rotation on just an external pipe rotator.
Yeah, I think you could do that with the, I think there's a function in there, like a remain in place, but I think by the time you get it all set up, throw it up in the positioner and let one of the guys weld it out. It's just one of those things. Time. Yeah, it's like what they were talking about earlier this morning. There's some things that really don't need to be automated. You'll spend a lot more time in trying to figure out how to automate it when you could have just thrown it up there and welded it out.
Done it by hand.
Yeah. For sure.
That's one of the things that I liked about, because I think we've been through 4 or 5 different sessions today.
Yeah.
Is the fact that it kind of, the one underlying issue, the one commonality that everybody seems to have in their presentation is these cobots, these robots, this automation, it's not taking away jobs. Mm-hmm. It's filling a void that's needed, but nobody's being fired because they brought automation into their building. It's not preventing them from still having a hiring need, by automating their facility. This is just kind of help, fill in that gap a little bit. And then at the end of the day, the welders aren't as worn out, because they're not handling it. They're not bending over welding on these parts all day. They're putting it in the fixture, slapping the button, and verifying everything is good. If it's not, they can adjust, settings on the fly, whether it's amperage, voltage, wire feed speed, whatever the case may be, travel speed, work angle. I mean, that's stuff that you still need the welder to do, because a robot's very similar to a calculator. Mm-hmm. If I put in the wrong formula, I'm going to get the wrong answer 10 out of 10 times. Mm-hmm. Same thing with a robot. If I program it wrong, it's going to weld out wrong parts.
Absolutely. I joke with a lot of people because they come in and they see some of our welding robots, and they're just amazed. That initial, like, what all can this thing do? And I'm like, well, robots are dumb. They're going to go right back to the same spot you program them to every time, whether that part is there or not. It's no different than, say, CNC machining. It's a known set of values, and it's going to be there. And So there's quite a bit of upstream things that you have to take into account to be able to implement even collaborative robotics. You still have to consider some upstream processes like cleaning and how you're going to tack up the part, planning for distortion, things like that. But yeah, the to be able to get the part to the robot and get the part out of the robot, that time, that programming time, or what we would consider setup time, the more that you can draw that down, the more versatile that machine becomes.
Mm-hmm.
So.
Now, you started off with one cobot back in 2012.
Mm-hmm.
How many cobot systems or automotive systems are you running into your shop today?
Well, 2019 we got the first cobot.
Okay.
We just set up and commissioned our second unit last week.
Okay.
Actually, yeah, we bought one of the Vectus units they had at FabTech this year, and so it's essentially going to be doing similar tasks. We have a lot of mechanical components that are associated with automation components in oil and gas that we're using the cobots to build. So it's pretty interesting because if you look back and see it, we've got welding automation being involved in building other automated components as well.
Okay.
So, yeah.
Now, you talked earlier about doing, is the cobot performing the welds on the threadlets?
No. We thought about trying that out. The problem with, once again, it ties it back to your threadlet. One threadlet they're not all made the same, and your integral branch connections, they're not all gonna be made the same. Even if they're coming out of, say, like a profiling system, you're gonna have some dimensional differences and variances, stuff like that. And the other thing you've got to worry about is complete joint penetration. A lot of companies like to, a threadlet being, it's one of the simplest fits as far as a pipe fitter could fit, but you still have to put a gap there. You still have to get a good root pass in there. The benefit we saw with just doing bridge tacking with the cobot, that freed up our fitters to fit up more complicated fits, so that spool piece that had 2 or 3 OLEDs on it, I had the cobot over in the fitting bay, and I had one of our entry-level fitters. He's actually able to do that while one of my more experienced fitters are fitting up the flanges and stuff. So they're working together, still 2 people, working together, but I'm not tying up a fitter on 200 threadlets when all those parts really have to hit the weld bays simultaneously, so they all follow their assembly out the door.
So you're actually using the cobot to tack everything up.
Yeah. That's been a big benefit, especially in the pipe shop. Structural components, brackets, and things like that. We'll program welds. There's really no sense in trying to set up tacking programs and things like that for that. But as far as the pipe, if it's a real simple fit and we got a pile of them, then we'll come up with a tacking scheme and put it on the cobot.
Now, how long does it take to program one of the cobots? Because that seems to be the big selling point. Is it's you can have the system up and running in an hour. How long does it actually take to program it for all these different custom parts and pieces you're doing?
Well, the salesman will tell you 5 minutes and you're making welds,
right.
But
that's on a T-joint.
Yeah, that's on a T-joint. Yeah, but depending on the part complexity, I would say to be realistic, anywhere from 15 to 30 minutes, really. I mean, and then of course you still want to do some touch-ups as you're proving out programs, but 1 or 2, maybe 3 welds in, you're up and running. Just load parts and let it rip.
So you can actually get that 30 minutes back because of how fast a cobot can actually operate compared to a human.
Easily. Especially the more parts that you have, volume kind of helps that out too. spreading that setup cost over more quantity of parts.
Yeah, that's the question I keep getting all the time is like, I'm thinking about getting a cobot or, getting into automation, should I should I do that? We don't do the volume. And it's, because it's a lot of, I work with a lot of custom job shops back in Florida, and they're all wondering, should I invest in a cobot? Because I'm having a hard time, getting people in here and getting them skilled up and, especially reliable people. And it's like, if you have a bunch of, if you're doing batches of parts all the time, then yeah. But if you're just doing like little onesies and twosies, I mean, probably not, the best use of your money.
Yeah. One thing I might, I would throw out there to somebody that is kind of in that situation, look at what it would cost to bring on somebody, bring on someone young and teach them the, what the weld needs to look like when it comes out of the cobot, and let them run the cobot on the parts while at the same time beefing up their skill level to be able to do it manually too. Because, that's an important thing too, is we don't want to be 100% dependent on welding automation or advanced welding features, because, you never know when you're going to have the day where it's just, you're going to have downtime. You're going to have outages. Something's going to happen, and you need to be able to. Your people need to be able to know how to do it manually still. So that's still important. But it's just utilize it as a something that's going to buy you some time. You can still get product out the door, while at the same time your entry level workforce is developing their skills, because that stuff takes time. I mean, you're not gonna be a jam up TIG hand after the first 6 months of welding. It's just not going to happen. But if you're putting out product with a cobot, and in that type of automation was put in strategically with some thought process ahead as to what we need to do upstream to make that work, now that buys you some time to bump your skill level up and still put out product.
Yeah. Now, because you were doing all this stuff manually prior to investing in a cobot cell, did you find that some of your older employees were a little apprehensive about bringing this technology in? I mean, were they kind of hesitant to adopt this type of technology into the shop?
Not really. They, in fact, it was my structural components manager, which, I mean, right now our oldest employee is probably mid-30s, so we're pretty youthful.
Ponce de Leon over there.
Yeah, I know, right? We got a lot of younger guys in there, but he was the older manager was the one that brought up the need or the process bottleneck, so to say, that he could see happening, and he's just being honest. Man, we're not going to be able to do this. We got to figure something out. And in fact, his words were, he goes, and I know we don't want to throw people at it because this is a 2-year contract. It's going to be done, and we're going to need something that, it would be nice to be able to utilize it on some other job shop work that I've got, but we really need this problem solved pretty quick because we're going to be in a bind.
So once you brought that equipment into your shop, did you find other uses for it that you didn't intend on when you originally purchased that capital equipment?
Oh, yeah. Yeah, the pipe fitting tack up and threadlets and integral branch connections. That was something that myself and one of my younger operators thought about because, once again, we saw a bottleneck. We saw something kind of developing there where, we were really overloading some guys. And he said, hey, cobot's open. We're not running catwalk brackets this week. Why don't we try to figure out how to do the OLED tacking over there? And so we got together and drew it up and put it together in SolidWorks and got them a model. And 4 or 5 hours later, we were tacking parts. So it was extremely beneficial. It was one of those things where I never even thought about would be a use, but ended up actually being utilized for that purpose more often.
That's one of the cool parts about the cobot too, is because it's portable. It's on a strong hand table,
yep,
or a Build Pro table, and you can just unlock the wheels, take it over to the next part of the shop, lock it down, plug it in, and you're up and running.
Mm-hmm.
So you can use it for a fitting area. Once everything's all fit up, you can take it back over here to the welding area, and you can weld everything out.
Yeah, they truck them all over the shop. We've got 2 different shops. We've got our special projects division, which is where we do a lot of like our job shop, problem-solving type stuff, and then our manufacturing shop where we're doing our product lines. And, they bounce back and forth between both of those shops depending on what the need is. So they really treat it as a tool. Like I said, they're treating it as a tool to aid in production, and the thought of it being a threat really never even pops up. I kind of joke with some people about it, about like magnetic drill presses. You're familiar with a mag drill. Whenever they came out with magnetic drill presses, the guys who were drilling those holes by hand, they weren't sitting over there saying, well, now they're going to take our jobs.
Yeah, they weren't complaining. I've ran a mag drill for years. Yeah. You're definitely not complaining about having to run a mag drill versus,
Absolutely not. And I think that's the start. I think we're at the start of seeing that kind of shift where we're viewing, because of all these other factors that we, and people can go back and forth on what they think is really affecting, the workforce shortage. And I honestly, I think it's a combination of a lot of different issues. But the fact of the matter is we need to view it as a tool, because that's what it is, and I read somewhere one of the guys, and I can't remember his name, he was talking about just that, how people view that, some people view that welding robotics is going to get rid of welders' positions and things like that. And he was joking, saying, we don't even have enough people to integrate the robots. We don't have enough people to put the systems in. What in the world do you think is going to? It's not going to happen. It's not happening. So it's definitely not a threat. I don't really think it should be viewed that way. It's the other way that I look at it too is, as a shop owner, as a business owner, I've got 20 or so people that ultimately I'm responsible for their paycheck. I'm responsible for their livelihood. And if I'm not continually exploring and checking out new processes and better ways to do things to make them more efficient, to make their careers in manufacturing longer and more rewarding, not burn them out, I'm really doing them an injustice, to be honest with you. I'm not setting them up for success, not just for my business, but for their careers as well. Because what will happen is, if I'm not looking at automation or all these different processes, or at least exploring that capability, my competitors are. And if I'm keeping things at arm's length just because of whatever principle I might have against, automation or something like that, I don't really think I'm doing I don't think I'm doing right by them. I'm not setting them up for success for sure.
That's a good way to look at it. I mean, constantly you're trying to figure out how can we do this faster? How can we do this better? And if the solution is cobots, you can't just say, well, I'm not going to do that because, I don't believe in automation. I don't believe in robotics. I don't want to automate my shop.
Yeah.
Like you said, you're doing your employees a disservice.
Yeah.
You've got to stay competitive. Otherwise, the bids aren't going to come in anymore.
Right.
It's actually going to be more expensive for you to perform the work.
Yeah.
And it's going to take longer. So
Absolutely.
You're going to start losing bids. You're going to start losing jobs and contracts.
Yeah. Yeah. And, I don't really see it. I don't really see it as a hindrance, to be honest with you. I think, we've done a really good job of, like I said, treating automation as just a tool. It's not going to replace anybody.
Mm-hmm.
It's far easier for me to take a welder and teach them how to use a robot, and it's less risky for me to take a welder and teach them how to use a robot than it is for me to get a robot tech and to try to get them to weld parts. Because and I mentioned that risk because a welder knows the way that puddle needs to look as it goes in. He understands the sound that it's making when it's short circuiting correctly, and when pulse is not working, those parameters out of whack. They understand, your gas flows, all your essential variables are coming to play. Where a tech that knows how to program the robot, they don't know all those things. So you're setting yourself up for a potential to make a lot of paperweights, if you're not
real
careful.
Quick.
Yeah, real quick. So, so I don't know. I'm past it. I don't really buy that whole robots are going to take our jobs type deal. We were already short on welders before robots even came along. We probably didn't even realize it.
Mm-hmm. I like the fact that you guys kind of realized it off the bat that this is just another tool.
Yep.
How do you keep your employees from fighting over who's going to use the tool for that day? Just because it makes work easier, it makes your life better, and able to get parts out faster. How do you prioritize and dictate what's actually the robot's going to be utilized for on a day-to-day basis?
Rock, paper, scissors. No. It really depends on the application. The benefit of us having two cobots is going to help out quite a bit. So that way, if my pipe fitters need the cobot for something they're doing, it's not going to put structural bracketing or structural fabrication behind on anything, and vice versa. So we don't really have a fight over who's going to use it. I think more so there's a fight over who gets to play around with it, when it's not getting used, because they'll be grabbing test pieces and stuff out of the scrap bin all the time and trying different programs, and I encourage it, because in that process they're learning how to program all those paths and teach all those different things, especially the younger guys, that may, like I said, still need time to develop their welding capabilities. They're getting a chance to develop their automation capabilities as well. So there may be a part where they think, because they're new to it, we just need to run the robot on it. Well, they'll go over there and try it, and then through all their headache, they'll realize that this is probably not something we need to automate.
Probably just easier to do it myself.
Yeah, by the time I did that, I could have done it myself. Yeah. So the funny observation I've noticed too is, so when we get some of the younger people over into the weld booths and they start training, doing some repetition on some of their entry level type welding, practicing welding T-fillets and practicing bead consistency and weld consistency on their caps and things like that. The funny thing is that I've noticed the guys that are running the cobot more often, their manual welds tend to be more aesthetically pleasing. They're more consistent. They're straighter. They're, it's kind of like, I would equate it to golf. I guess I don't know if you're a golfer or not.
No, I've whacked a couple balls.
Yeah,
but...
yeah. Well, so if you're familiar with Tiger Woods, right?
Mm-hmm.
So
I've heard of him.
So Tiger, whenever he first came on the scene, his swing coach was a guy by the name of Butch Harmon, and Butch Harmon was really big on visualizing the shot before you ever hit it. And his theory behind that was, if you can visualize what the shot's going to look like, you have a higher probability of hitting that shot, or if your misses aren't going to be as bad. So my theory when it comes to that is, they're sitting at the cobot, they're watching the weld puddle go in consistently. They're seeing all these consistent movements. They're seeing the pauses at the toe of the weld and watching that puddle, all those different characteristics. They're able to see the weld template where they can see the amperage, voltage, travel speed, all of our essential variables that are important. They're able to see what happens and the sounds that it makes and everything that happens when those variables are out of whack. So they're carrying that. So they're getting all this feedback visually. They're carrying that over into the weld booth whenever they're going to weld manually. It's like a subliminal thing almost. It's kind of funny. So
I could see that, because a lot of times, like even as an instructor, like I know exactly how a weld needs to be performed,
mm-hmm.
To get the anticipated outcome. And I'll try to convey that information to the student. So I know all of the variables, the amps, the volts, the wire feed speed, contact tip to work distance, the oscillation, the travel, all that stuff. But once I put my hood down, I might get distracted, and I might start going all over the place and not realizing. But like when you take all that information that I know how it needs to be put down, and I put that into the robot, that's exactly what the robot's going to do. So now you're watching exactly how it needs to be performed.
Yeah.
And you're just developing that repetition. That's why I tell people all the time that's why robots make such good welders, because they just do this. It's all repetitive. So if you want to run a nice looking bead, you got to stay consistent throughout the entire length, or circumferential, of that weld.
Yeah.
You've got to stay, consistent the whole time. And as soon as you break consistency, that's when you're going to see the discontinuities or the ununiformity in your bead profile.
Yep.
It's because you weren't consistent in that area. So watching that robot, how consistent it is, like you said, when it pauses on the left side, when it pauses on the right side, it's equal the whole time.
Mm-hmm.
So you're going to see that day in and day out and understand which variables have the greatest, variability when you're welding, and you're just going to start applying that when you flip your hood down.
Yeah, absolutely. The other thing that I've seen is a really good benefit that I didn't really anticipate was, in regards to our people, the youth that are entering the workforce in manufacturing. We consider them, the iPad generation. The way that they learn and the way that they take in all of that process feedback is a lot different from what you and I do, because you and I probably come from the age where we were sitting next to a mentor or an instructor, and we just tried to mimic what he was doing.
Mm-hmm.
They're far more visual learners than we are, and I found that to be something with welding automation, or even something like CNC plasma tables. When we transitioned to a newer table, we went with touchscreen. And it was like I had to hit them with a stick to get them to stop fighting over using the plasma table, which it did literally the same thing that the old one did. It's just this one had a touchscreen.
Mm.
Everybody in the whole shop wanted to run the plasma table.
Everybody wants to play with a new toy.
Yeah, but it's still that case. I've had it maybe 8 years, and it just the way that they process information is a lot different. And I think that, we as instructors and we as mentors and company owners and stuff, we really have to pay attention to that and not really push that off as just being something dumb that the next generation does,
Mm-hmm.
So because it can be beneficial to us in business, and it can also be beneficial to them as well as far as developing careers.
Yeah. I was talking to some of the folks that do automation. And I was like, you guys need to put like a scoring system on there, because then you got everybody in the shop fighting over the high score.
Yeah.
Welders are a very competitive breed.
Absolutely.
And you figure out a way to attach a score to that, and your productivity is going to go through the roof.
Yeah, they were trying, I think a couple of weeks ago, they were trying to get the cobot to mimic taking a break and smoking a cigarette, So I'm like, what are you guys doing, But yeah, so something like that being put in the hands of this next generation, I have really good hope for the way that they're going to take it and really do things that I don't think we probably understand, just because of the way they process information.
Mm-hmm.
So
they're going to be able to push it to its limits.
Oh yeah.
Well, Corey, it's been a blast having you on the podcast, man.
Thank you.
It was great meeting you out here in in person. And like I said, great presentation. Especially hitting it up the time slot that you had. I mean, it was very good.
Well, I hope I didn't put anybody to sleep in nap time.
No, it was a great conference so far.
I am much better at welding than I am presenting, so I appreciate I appreciate that.
I'm in the same boat as you are, man. I'm probably the captain. All right, ladies and gentlemen, thank you for tuning in to this month's episode of Weld Wednesdays with AWS. I hope y'all enjoyed the episode. Join me next month for the upcoming Inspection Expo and Conference taking place in Austin, Texas, where I'll be chatting with another expert in our industry. If you'd like to attend the IEC conference, head on over to aws.org/conferences, or just click the link in the show notes. For more information on the American Welding Society and how you can get involved and fast-track your career, head on over to aws.org. I hope you'll have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.